Hello and welcome. Today I'm going to showcase this bench test using a CompactLogix PLC that has a Ethernet and serial port connections. The Ethernet port is connected to a router, and the reason for that is because my laptop only has two USB ports, and I like to use a mouse, and the other port is to use the USB to RS-232 adapter. So that's why I have the computer connected to the PLC using the Wi-Fi to that router. So right now I have this program running on the PLC, which is just a lab test of error handling routines, and the goal is to have the PLC send ASCII values or strings over the serial port to a device. In this case, I'm emulating the device using the PUTTY serial terminal. And also I have a little HMI here written in advanced HMI on Visual Studio, which has a integer display, a tag. Here it's a numeric value, integer value. I have two booleans here, two toggling internal bits on the PLC, which trigger, this one here triggers a watchdog, and this here triggers a timer negative preset value. Okay, so in the PLC project, I have a fault handler task. Inside of it, I have a fault handling program with a subroutine called watchdog. The watchdog is written in text language, and what it does, it gets the system value, the program, and it gets the major fault record, and then all it does, it's just converting to strings the fault type and the fault code here. It also gets the wall clock time, and all it does here is just concatenates the values for the hour. If the hour is less than 10, it will append a space, and if the minute is less than 10, it will append a 0 to it, and if the seconds is less than 10, it will append a 0. This is just to make the text message consistently the same length, just because I don't like, to have short and long strings. This is just my personal preferences, and it will then concatenate all the values, which is the error code, and then the time, and then the colons and spaces in between, and then append it into a longer string. That longer string is then the length of that is passed to the serial port control structure, and then sent over the serial port with the ASCII write function here. So this is just the watchdogs. It gets executed on every major fault, which I'm testing for watchdog and timer with a negative preset. In the main task, which is a cyclic task, I have, let me just open that up here. The main program and the main program, the main subroutine and the main program of the main task. It's a long sentence there. Uses the first scan bit to clear the major fault here. To clear the major fault subroutine, it's a subroutine inside the main program. All it does, it sets zeros, all those codes on the fault record, and then sets the system variable to 0. This is just to clear the error. And also inside of that, I got mortgage. Mortgage is what it does, what it says. It's a mortgage calculator. So it starts with a capital And the capital is obtained out of a catalog of values, and the values are selected using this rotary switch. So any of these BCD settings, you can see the BCD switch is connected to the first four pins of the input terminal strip. It goes up to 9. There. I go back to 0. So it takes those values and then has the interest, the monthly payment, the monthly escrow, and it starts with clearing the initial counters, which is amounts, and the accumulated interest, and it starts to do the mortgage calculation until the capital is less than 0. So it will start with monthly interest equal capital times interest rate divided by 12. This is a monthly interest. The monthly capital is a monthly payment minus the monthly escrow minus the monthly interest. The capital then is equal to capital minus the monthly capital payment. And then months equals months plus 1. Accumulated interest equals accumulated interest plus monthly interest. So this is a recursive while loop. And here's what I use this to catch the watchdog. So if you add a capital that is too large, it will take too long to calculate because it will do this several times. Every month is a iteration. So if you do a watch now, and you want to watch how many months it takes for this capital right now. I also have this little, like I said, it's HMI written in Visual Studio using advanced HMI. And if I toggle this bit, it will, the main routine, start the mortgage. It will take the value out of the catalog of capitals, and then it will do the mortgage calculation with that. So if you go and look at the mortgage and you look at the I'm going to type in my quick watch mortgage, you got the months, the capital. Right now it's insane. That's a lot of months. So if I go there and do the, right now it will only take 7 months because the capital is $2,400, so it will only take you 7 months to complete this. But if you change this to say 6, let's find out how many months it will take you to come out with this mortgage. So the capital for that setting is $115,200, and it will take you 1,300 months. So that is a lot, like 100 years to pay this house with this payment. Okay, this is unrealistic, of course, but the goal is to, right now, if you look at the main task here, you look at properties, and you look at monitor, the maximum time, the last maximum time it took it almost 38 milliseconds to do this, the whole scan of all this. So if I were to, let me just minimize, let me just show everything here. I got the HMI here. I got the serial terminal, which is going to receive whatever ASCII information is coming out of the COM port of the PLC and show it in this PUTTY terminal here. And I'm going to increase this to the next level here. So this is going to be 7 is twice that, I think. Okay, so right now I'm going to start the toggling, and you watch if the PLC faults out. Okay, the PLC faulted out. It has a fault, a major fault. And right now, right now it exceeded 500 milliseconds. to get the last fault here. The last fault occurred was a type 6 fault, code 1. It happened on 11/21/35. And if you look at what the major faults are on your documentation, let me get here, documentation, Visual Studio, CompactLogix, ControlLogix fault codes. Okay, so if you go to major faults and you scroll down to the chart, I'm going to try to maximize this. I'm going to try to hide this and maximize this. Full. Okay. Fault code 6. Okay, fault code 6. Type. What the result is type 6. This column here is type, and code is 1. This is a task watchdog expire. User task has not completed in a specified period of time. A program error caused an infinite loop, or the program is too complex to execute as quickly as specified, or a higher priority task is keeping its task from finishing. So what happened is that if you look at click here on the PLC faulted running taskbar, you go to not clear faults, but go to faults and look at the major faults. It says the routine mortgage caused this. It took too long, and it took too long. Imagine this calculation taking 18,115 iterations to complete. It exceeded 0.5 seconds. That's why you're getting that. Okay, so if you clear the faults are clear, and if I transition from running from program, right now it's in program mode because it faulted out. If I go back to run mode, change control to run mode, yes, you're getting this on the serial port. So as soon as the PLC went back into running mode, I get it started running at 11/24. So you're getting the information of when the PLC went into fault state, a major fault, it caused it to stop running, and then when it went back into running mode. Okay, the next thing I'm going to do now is to I'm going to close this here. Go to main, and in main I have this bit 1, which is this toggle button here. This toggle bit will load a -1 into a timer preset. And if you know anything about timers in Rockwell, is that you cannot have a timer timing negative. I mean, it has to be 0 or higher. So a -1 is a no-no for timers on Rockwell. So it will cause a major fault. So this timer will load a -1, will move -1 into the negative timer preset, which is right now it's 100, and then it will try to start the timer. That will cause a fault, and this is all triggered by this toggle bit. So I'm going to toggle that, and you watch what happens. You got a fault. Great. Last fault type 4, code 34. If you go, what was that again? 434. 434. Right here. A timer instruction has a negative preset or accumulated value. So you're getting this through a serial port. What is this? What can you use this for? Well, here's a goal. I can have the PLC outputting that into, say, a Raspberry Pi, because it's serial, it's ASCII. I can have the PLC send those values through the serial port to a Raspberry Pi, and a Raspberry Pi could then take those values, use this table of information here, and then email you or someone, or log it into a database, or do whatever I want with it. Post it into a web page, or do something with it. You can get useful information of the PLC health status this way by doing error handling. So this is the ultimate goal, to get this information out into an external device, such as a Raspberry Pi or some other device that can then use that to do some other more useful things, like log faults and then record the time it happened, and then do reporting, email service people or management, or do something with it. So that is the ultimate goal of this. In later installments of this video, I will hopefully have a Raspberry Pi set up. I have several of those. I have one sitting right here that I can connect to. So all I need to do is take the serial port, convert it to TTL levels, actually 3.3 volt levels, with a UART to converter, which are they're inexpensive, and then have the Raspberry Pi handle those messages. Well, that's the next step. Thank you for watching.